Hello engineers, welcome to third lecture of heat exchanger training series. So in this video, we will discuss about types of shell and tube heat exchangers guys. So before diving into the topic, if you are new to my channel, please subscribe and hit the like button guys. So let's get into the topic. Types of shell and tube heat exchangers. So the first one is based on geometry guys. Based on the geometry, the shell and tube heat exchangers are classified as three types. One is fixed, next one is floating, and next one is U-tube type. The first one is fixed type guys. So fixed type heat exchangers have a tube sheet that is directly welded to the shell guys. In floating type, in floating type heat exchangers, the tube sheet is not fixed guys. So in floating type, one side is fixed and the side is mobile guys. So this will reduce thermal stresses. And next one is U-tube type. U-tube type heat exchangers have a U-shaped tube bundle which allows for more efficient heat transfer. So this is all about based on geometry guys. And next one is based on the services. So based on the services also, shell and tube heat exchangers are divided into three types, that is class R. So class R is for refinery applications, class C is for general applications, and class B is for chemical applications guys. If you are designing your heat exchanger for refinery applications, you need to follow class R. And if you are designing your heat exchanger for general applications, you need to follow class C. And if you are designing your heat exchanger for chemical applications, you need to follow class B type. I hope you understand these types of shell and tube heat exchangers. So let's discuss in detail, guys. The first one is fixed type. So the first one is fixed type. So this is the general layout of shell and tube heat exchangers, guys. So when we look at the cross section of the heat exchanger, we notice that it consists of bonnet. The bonnet is also called channel cover, guys. This bonnet is also called channel cover. Generally, in pressure vessel, this is head, right? But in heat exchangers, we call this one is channel cover or bonnet. And next one is straight shell. So this is the straight shell, guys. And tube side and shell side elements are there. So the tube side elements are the parts of the heat exchanger that come in contact with tube side only. So these are the tube side guys. So tube side, whatever the elements connected to the tube side, so that are called as tube side elements. So generally, we'll consider bonnet, channel, and the nozzle inlet and outlet. So all these are generally referred as tube side elements. And there are, on the other hand, the shell side elements also there. The shell side elements are elements which is connected to the shell. Okay, for example, these papil plates. These papil plates are connected to the shell, right? So this is a shell side element, guys. So I hope you got this point. And the nozzle inlet and outlet also considered as shell side elements. And whatever the tube sheet is welded to the shell, guys. The shell and the tube sheet are also considered as shell side element only. I hope you understand what are shell side elements and what are tube side elements. It is important to understand difference between tube side and shell side elements, guys, because the design pressure and temperature must be applied accordingly. While designing the tube side elements, we need to consider design pressure and temperature according to the tube side elements. So while designing the shell side elements, we need to consider shell side design pressure and temperature. Okay, I hope you got that point. So let's see the principle. So generally, one fluid entered to this inlet gas tube inlet, and it will flow through the tubes, and it will get out from this outlet, guys, tube outlet. So this is the one side flow only, one pass flow only, and the other fluid is flows through this shell side flow, and it will travel like this, guys. So it will travel like this. So it will increase the heat transfer flow rate, and it will out from the shell side. So this is the general principle of heat exchangers, guys. I hope you understand. But in a fixed type heat exchanger, there are two main problems are there. So if you see here, these tubes are fixed here, right? These tubes are fixed to the tube sheet, and tube sheet is fixed to the bolted to the this tube sheet is bolted to the flange, guys, at both ends. So there is no provision for expansion contraction of these tubes. So due to the temperature difference between these two fluids, the expansion and contraction generally occurs, right? But here we are not providing any, we are not given any expansion or contraction provision here. We are fixed. So that's why here thermal stresses are induced. And also there is one more problem, that maintenance is not easy, because here we are bolted to the flange, right? So it is difficult to do mechanical maintenance. So these are the two main problems, guys. So to rectify these problems, we will use floating type heat exchangers. Okay, in this type, the fluid enters the tube from the top, and flows to the other side before coming back, right? The advantage of floating head type heat exchanger is it eliminates problems associated with fixed tube heat exchangers, guys. In fixed tube heat exchanger, we see thermal expansion, thermal stresses induced and mechanical maintenance problems, right? So here the two problems are resolved. One side of the tubes is fixed here. So one side of the tubes is fixed here, and the other side is not fixed to the tube sheet. Okay. So there is a provision for expansion or contraction here. So there is no thermal stresses induced in this case. And next one is mechanical maintenance. Here maintenance also easy because here bolted to the tube and this uh, bonnet, guys. So it is not connected to the shell. It is not connected to the tube. It is not connected to the tube. So we can easily remove from this tube, guys, and we can clean it out. Okay. So these two problems are rectified in floating type heat exchanger. So one of the fluid enters from this nozzle inlet, guys, tube side, and it will flow through the these tubes, and it will exit from the other side. And the other fluid enters, hot fluid or cold fluid, enters from this nozzle inlet, and it flows through the baffle plates, so which increases heat transfer rate by moving like this, and it will out from the under nozzle inlet. So due to this, heat transfer takes place between the two fluids, guys. I hope you got the principle of floating type heat exchanger. So here we are eliminating two main problems, and this is the general principle of heat exchanger. I hope you understand. And next one is U-tube type heat exchanger, guys. The U-tube type heat exchanger is a simple type heat exchanger compared to the floating type heat exchanger, guys. It consists of U-tube shapes. Here, your tubes are generally shaped into U form. So this will decreases thermal stresses, guys, because here large radius are there, right? So generally decreases the thermal stresses. But here main problem is maintenance. So the setup is inside the tube, right? The setup, the whole setup is inside the tube. So it is difficult to clean mechanically. So mechanical maintenance is difficult, but you can clean by using a pressurized fluid, guys. You can inject pressurized fluid in these tubes and you can clean it. But mechanically, it is not possible. It is important to select which type of heat exchanger is suitable for our applications. So based upon the application, we need to select either fixed tube or floating tube or U-tube type heat exchangers, guys. And next one is there is one more type, that is number of passes, according to number of passes, guys. So I already told you one pass. The first one is one pass. So this is the simple. The fluid enters from this side and it will flow to the tubes and it will leave from this side, guys. So one pass is the simplest type of pass in heat exchangers where the fluid flow from the one side to the other side in a single pass. There is no other pass. This is one pass, guys. So your front head, this is the front head, right? If the front head see looks like this, and the rear head looks like this. So this is the front view and rear view of your tubes. And next one is two pies, guys. A fixed type tube sheet can be divided into two parts, guys. Here you can observe that partition plate. This partition plate allows you for two pass arrangement, guys. I hope you understand. So one side the fluid enters this side and it will flow through the tubes. This is one pass. This is the first pass, guys, and it will again enter to these tubes. That is second pass. So like this, two pass completed, and after that it will come from this outlet side. I hope you got. This is the two pass, guys. Right? If your front head is looks like this, there is one partition. This is the partition line, and rear head there is no partition. Okay. So this is all about two pass, and we have four pass also. So in four pass, your fluid enters like this. So and you have two partitions. And you have two partitions, and rear hand has you have one partition. Okay. So your this is the front view and rear view of your tubes, guys. So generally your fluid enters from that side and it will go to first pass. This is first one, and it will come from this side. This is first one, and again it will enter to the second side. This is second one, and it will come from the second side, guys. This is second one, and again it will enter to the third side, and it will come from this side, and again it will enter to the fourth. So like this, it will complete four passes. Okay, why we are using one pass, two pass, four pass, and six pass, guys? Because to increase the heat transfer rate. According to the application, we will use this one pass, two pass, and four pass, guys. So I hope you understand this concept. If you think this content is valuable, please share to your friends also. Thank you, guys.